Hello APC Mechanics students in Unit 1 Kinematics, Class 16, 1.2 Projectile Motion, Part 2. Then in today's video we're gonna solve some exercises related to projectile motion linked to what we have explained previously. But before we do that, let me start with section 1, which is a recap. Then for a projectile motion, both symmetric and non-symmetric projectile, the equations of motion are given by. So now I'm gonna remind you by the equations of motion, but let me explain what's happening here. So we have a projectile motion launched with an initial velocity making an angle theta with the horizontal above the horizontal. The velocity along the x-axis is constant and it's given by Vx0 is V0 cosine theta. Then let me remind you what's happening here. The horizontal acceleration is given by 0. And what about the vertical acceleration? Here the positive y direction is up, and we know that the gravity is down. Then in this case ay is given by minus g. And remember that in the equations of motions, ax and the components of the acceleration appears explicitly. For this reason we are interested, or it is important to differentiate for the component of the acceleration related to the positive direction, whether it's up or down. Now, so because the acceleration is 0 along the x-axis, then the speed is gonna remain constant, which is given by v0 cosine theta. And during the upward motion, the velocity will decrease at a rate of 10 meters per second squared. During the downward motion, it will be generated back at a rate of 10 meters per second square. And remember that slices of same height will carry the same speed, however opposite velocities along the y direction. Along the x-axis, the position is given by x0 plus v0 cosine theta t. This represents the speed along the x-axis, which is given by Vx is V0 cosine theta. And along the y-axis we have y is y0 plus V0 sine theta. This would be the initial velocity along the y direction, and minus half gt squared. The minus sign reflects this idea here. And Vy would be given by V0 sine theta minus a gt. And we have determined the expression of the maximum height, given that it's a ratio between v0 squared sine squared theta over 2g, and all of these hold for both symmetric and non-symmetric projectiles. Then let's start with exercise 1. A projectile is launched from top of a 15 meters tall building at a speed of 25 meters per second at an angle of 50 degrees above the horizontal. The horizontal distance from the base of the building to where the projectile lands is most nearly. Then the best way to approach such a problem is by doing a sketch. Let me say that this is the building, and that would be the launching point. We have launched a projectile with a speed of 25 meters per second, making an angle 50 degrees above the horizontal. We need to choose the origin, and basically in most of the cases the origin will be the launching point. Then let me say this is the origin, so this is the x-axis, and that would be the y-axis. So in this case, or we are in the case of ay is minus a g. Now we are interested in determining the horizontal distance. This will follow a parabolic trajectory and it's gonna hit the ground. This is the ground and this is the building. This is 15 meters tall. It will hit the ground somewhere here. We're interested in determining this position. So how we're gonna proceed with that? Remember that because we have the position, so we have y, we can determine t. By determining t, we can determine x. So first let me write the equation related to the vertical position. Then y is given by y0 plus v0 sine theta t minus half gt squared. Considering that, so let me erase that and write it again. Then y is y0 plus v0 sine theta t minus half gt squared. The initial vertical position is 0, coincides with the origin. We have the initial speed, we have the launching angle. Now what about the vertical position? Because we're interested in determining x at this point, so we need to replace y by this value here. Notice that up is positive, down is negative, so y would be replaced by negative 15. The negative 15 equals v0 is given by 25, and that would be sine of the launching angle, which is 50 degrees, multiplied by t, minus half, g it's considered to be 9.81 or 10, and t square. Now rearranging for this quadratic equation and putting it in the decreasing power, that would give us minus 4.9 t square plus 19.15 t plus 15 is equal to 0. Then what I have done is just remove this to the other side and simplified these. And remember that this is in degrees, so we should compute sine 50 degrees in the, or this in the degrees mode. Now we have two solutions. The first one is given by t1 is 4.58 seconds, or t2 is given by minus 0.67 seconds. This is rejected because time is absolute, is always positive. Now what do we have? We have the vertical position, we have determined the time. Now we can determine x. X is given by x0 plus v0 cosine theta t. The initial horizontal position is 0. The initial speed is given by 25, and the angle is 50 degrees, and the time, now we know it's 4.58. Plugging that on the calculator, we're gonna get a value which is given by 73.59 meters, and the closest to that would be D. Now exercise 2, at time t is 0, a ball is thrown with initial speed v0 at an angle theta above the horizontal. Air resistance is negligible. Which of the following best represents the speed of the ball as a function of time t, while the ball is in flight? We know that during the flight we have two components, vx and vy, but they're asking us for the speed, which is the combination or the sum of vx and vy, and this is given by the Pythagorean sum. Vx is v0 cosine theta t, whereas vy, it starts from initial value given by v0 sine theta, and it will decrease by the linear term minus gt. Then the speed in this case is given by the radical of vx square plus vy square, and that would be v0 cosine theta to the power of 2 plus v0 sine theta minus gt to the power of 2, and the correct answer in this case would be C. Now, which pair of equations can describe the path of a particle moving with zero acceleration? So if we're following the order, which is 0 into constant into linear into quadratic, in agreement with the order of A into V into X, then A is 0, V is constant, the positions should be linear. Then in this case the correct answer in C is C, and you can verify that by double derivative. So if you derive this twice, it's gonna be 0. If you derive this twice, it's gonna be 0. Now exercise 4, a ball is struck at time t is equal to 0 and follows the parabolic path shown in the diagram above. The following graph shows quantities possibly associated with the motion as a function of time t. Assume that air resistance is negligible and that the positive directions are upward. This is important. Positive is up. Why this is positive is up? Because this is gonna put a condition on the sign of the acceleration. Positive is up, gravity is down, then AY is given by minus g. So good so far. Now assume that air resistance is negligible and that the positive, okay, which graph represent the horizontal component of the velocity of the ball? We know that the horizontal component of the velocity is constant and it's considered to be positive. And indeed, if you check the choices, the only positive or the only constant velocity is given by E. Now exercise 5, a ball is struck at time t is equal to 0 and follows the parabolic path shown in the diagram. The following graph shows quantities possibly associated with the motion as a function of time t. Assume that air resistance is negligible and that the positive directions are upward. Positive is up, which means that AY is given by minus g, which is minus 10 meter per second square. Which graph represents the vertical component of the velocity? So if you look at the order, which is 0 into constant into linear into quadratic into A, V into X. If A is constant, then V is linear, then the shape of the VT graph is gonna be either something like this or like that. This is negative, which means the velocity will decrease, then the shape of the curve will gonna be something like this, and the correct answer in this case is D. Now exercise 6, a rock is thrown from the edge of a cliff with an initial velocity v0 at an angle theta with the horizontal as shown above. Point P is the highest point in the rock's point P is the highest point in the rock's trajectory and point Q is level with the starting point. Then if you consider this part of the projectile, this is going to be a symmetric projectile. If you consider that complete part, that would be a non-symmetric projectile. Assuming a resistance is negligible, which of the following correctly describes the horizontal and vertical speeds and the acceleration of the rock at point P? Alright, so at point P, this is the maximum height reached by the projectile. We know that, first of all, Vx is always constant, and it's given by V0 cosine theta, independent of any point along the trajectory. At the point P, this is the point of maximum height, and it's dictated by Vy is equal to 0, and all points of the projectile are given by acceleration along the x-axis to be 0, and acceleration along the y-axis is given by, so if it's up, then it's given by minus g, if it's down, it's given by plus g. So I'm gonna say plus or minus g, and the magnitude of the acceleration would be given by g, which is the Pythagorean sum. So directly, for example, we can eliminate this, and we can eliminate that. We're left with A, B, and D. So the horizontal speed, okay, we can directly eliminate this because we know that we have a horizontal speed, but the vertical speed at the point B is given by 0, so the correct answer in this case would be A. Now exercise 7, a rock is thrown from the edge of a cliff with an initial velocity v0 at an angle theta with the horizontal as shown above. Point P is the highest point in the rock's trajectory and point Q is level with the starting point. Assume a resistance is negligible. Which of the following correctly describes the horizontal and the vertical speeds and the acceleration at the point Q? Perfect. So at the point Q, the acceleration in magnitude would be given by g. We know that Vx is considered to be constant, which is v0 cosine theta, but notice that the starting point and the point Q happen to lie in the same slice of height, which means that Vy here, which is given by, so Vy here is given by v0 sine theta. So the point Q will also have a vertical velocity of magnitude v0 sine theta, but the direction would be downward. Then in this case, Vy would be in magnitude, okay, let me say minus v0 sine theta, that would be at the point Q. Now let's start eliminating directly. We have a horizontal speed, then this should be eliminated, and this should be eliminated as well. Now we have acceleration at all times, then this should be eliminated. We have a vertical speed, then this should be eliminated. For this reason, the correct answer would be D. Because, let me say again, this point coincides with this point for the same slice of height, and the starting point has a vertical velocity given by v0 sine theta, which is the same as q. So we're talking about speeds and not velocities, so D is the correct answer. Now exercise 8, a projectile is launched with a speed of 40 meters per second and an angle of 30 degrees above the horizontal as shown in the figure below. Okay, that should be the figure above. This projectile lands on a plateau 3 seconds later. The height delta y of the plateau is most nearly, so this is straightforward. We have time, we can calculate delta y. Then delta y in this case, or let me say that we know that y is given by y0 plus v0 sine theta t minus half gt square. So remember that this term would represent vy0, and this is ay. Here I'm assuming the positive direction to be up. Now if you drag this to the other side, independent of the origin that you're choosing, you're gonna have that delta y would be v0 sine theta t minus half gt square. Also you can say that this is the origin, and y would be given by 0 plus v0 sine theta t minus half gt square. Whether you determine delta y or y, that would be perfectly the same. Now we have the time, which is 3 seconds, we have the initial speed, we have the launch angle, we have all the ingredients. That would be 40 sine 30 multiplied by the time t, which is basically 3, minus half 9.81 multiplied by 3 to the power of 2. Plugging that on the calculator, we're gonna get a value of 15.85 meters, and the closest to that is 15 meters, then the correct choice would be A. Exercise 9. A projectile is launched with a speed of 30 meters per second and an angle of 60 degrees above the horizontal. The projectile lands on a ledge that is 15 meters above the launch point. As shown, the horizontal and the vertical components Vx and Vy respectively of the velocity when the projectile lands are. Then as we know that how to approach this problem, we have y, we have it. Then once we have y, we can determine t. And once we have t, we can determine Vx and Vy, because we know that these appear as function of time, knowing that we have the initial speed and we have the launch angle. Let's consider this to be the origin. This is the x direction and this is the y direction, so we can make use of the equations of motions we have determined previously. We know that Vx is given by V0 cosine theta, and Vy is given by the initial vertical velocity V0 sine theta minus gt due to the gravity which is downward. Now we need to determine the time. We can refer to the vertical position given by y is y0 plus v0 sine theta t minus half gt square. Now we know that y0 is 0. Y, what is the vertical position at this particular point? 50 meters up, then that would be 15. Then 15 equals V0 is given by 30 sine 60 multiplied by t minus half 9.81 t square. Now dragging 15 to the other side and simplifying and put it in the form of decreasing power, we're gonna have minus 4.9 t square plus 25.98 t minus 15 is equal to 0. And we will get two solutions given by 0.66 seconds, or t2 is given by 4.64 seconds, and both times are positive. Then which one we're gonna choose? We should interpret the results properly. Now if you look carefully, for 15 meters this happens for two instants. For the same slice of height, the projectile will reach a vertical position of 15 meters at two instant times t1 and t2. Because the motion is happening from left to right and time evolved, this happens for 0.66 seconds and this happens for 4.64 seconds. Then we're gonna assume that this is the correct answer. Now after we have the time, we can plug it here in order to get the values. Now Vx is independent of time. The initial speed is 30 multiplied by cosine 60. Doing that on the calculator, we're gonna get a value of 15 meters per second. So we're either in A, B, or C, or E. What about Vy? We know that Vy in this case would be negative because at this point the vertical velocity would be downward. Vy is given by V0, which is 30 sine 60 minus 9.81 multiplied by the time t, which is 4.64, and plugging that on the calculator. Let me erase this line also. That would be a value of minus 19.54 meter per second, and in this case the correct answer is B. Now exercise 10, a student throws a metal sphere which follows the path shown above. If a resistance is negligible, which of the following is the correct relationship between the magnitude of the accelerations AK, AL, A, and AM at the 3 points shown? We know that along all points of the trajectory the acceleration remains the same, which is given by A. And finally, exercise 11 as an exit ticket for today's video. A cannonball is shot from the top of a 30 meters high hill at a velocity of 25 meters per second at an angle of 40 degrees above the horizontal and lands on the ground below. The speed of the cannonball at the top of its path, it's most nearly, so here no need to do a sketch because this is straightforward. At the top of its path, this is given by the maximum height, which is Vy is equal to 0, but we are interested in the speed. The speed is both Vx and Vy. Vy is 0, it's left to determine Vx. Vx is constant along the path, and it's given by V0 cosine theta, where V0 is the initial speed and theta is the launch angle, which is 40 degrees. Plugging that on the calculator, we're gonna get a value of 19.15 meter per second, and the closest to that is C. Then thank you for watching, and see you soon in a new one.